I assume I can start, right? Yeah. Okay, so hi everyone. Thank you very much for joining this session. My name is Nicola Corti, and today we're going to talk about rolling out like a rock star. So, mandatory slide about myself. I work as Android infrastructure engineer at Spotify in Stockholm, Sweden. I want to spend a couple of seconds on what infrastructure means here exactly. I mostly spend my day working on SDKs and tools for other Android engineers. So that's like a little bit different than like the canonical Android engineer. You can find my contacts on Twitter as Corti and also on GitHub. And by the way, if you like running, make sure you scan this Spotify code. Like if you go inside the Spotify app and search, there is like a camera icon. You can scan this code and you can subscribe to my running playlist. I really love running and like make sure we are synced on the same tune. But now let's get started. And to get started, I want to start with a little bit of history, and I need to start with this. So if you don't know this is ABBA. Why I'm starting with ABBA? First, because I love them. Second, because they're Swedish. And also Spotify is a Swedish company. We are based in Stockholm. And let me actually stop. Yeah. And the reason why I'm telling you that is like, if you happen to be in Stockholm, make sure you stop by at the ABBA Museum because it's amazing. You will enjoy that for sure. But ABBA is also the name of our first experimentation framework. And I think that the name was just like genius because ABBA, Sweden, music, Spotify, and also ABBA, it's the best tool for running A/B testing. So I want to start from here. As I said, ABBA was our first naive experimentation framework at Spotify. We use that as the foundation to running all the experiments and rollouts that we run inside the Spotify app. Unfortunately, it came with some drawbacks. Specifically, it was really hard to scale. Like once Spotify started to grow more and more, it was really hard to keep having ABBA following our growth piece. The problem with ABBA was everything was designed as global. So imagine that you have like a single file on Android where you have like all of your flags defined. And once you reach like something like 100 Android engineers touching the same code base, it gets really complicated to touch the same file concurrently. And it's just like a mess from the ownership point of view. It was hard to maintain, as I said, because it was not designed to fulfill our needs. And also it was not flexible enough. First, it was hard for us to adapt it to our developer experience that we wanted to offer. And also, we have a lot of data scientists at Spotify. It was really complicated to define custom metrics. So ABBA was really elementary. And we spent quite some time recently reshaping it. Specifically, we divided ABBA into different components and we rewrote them from the ground up. So today, I'm here to share with the rest of the community our work and with the idea of giving inspiration to others that might just want to start doing experimentation or feature rollout. So the tool that I'm going to present today, it's called remote configuration, and it's a tool that we use internally at Spotify to do A/B testing and experimentation and feature rollout. So I want to give first a couple of disclaimers. There are a couple of topics that are extremely crucial for running proper A/B testing and experimentations that I will not touch today. And here's why. The first one is all the data science behind A/B testing, specifically how you do user allocation. Whenever you're running multiple experiments, you want to make sure your users are not biased by being inside a previous experiment. So you want to make sure they're fully random. I will not touch this. We could give an entire talk only on this, and it's extremely interesting. But at the same time, this is like a little bit out of scope of what I want to talk about today. And then I will not mention analytics. So analytics are a fundamental part of an experimentation framework because they allow you to understand what your users are doing, either doing event reporting or on the higher level, talk about user behavior. Like, is the user clicking on a certain button, is more interested in a certain screen rather than another? You need those to understand what users are doing. But again, we could give another talk only on this. So they will be outside of the scope of this talk. So whenever we talk about feature rollout, experimentation, A/B testing, the code that an Android engineer has in his mind looks more or less like this. You have if then else. You check if a feature like showing lyrics of a song is enabled or not. And if it's enabled, you want to show a certain experience, like in this case, the real-time lyrics experience. If it's not, you want to fall back to a default experience. Unfortunately, it's not that simple. Like, the code here is really trivial. That could be like a Boolean guard like this one. It could be like something a little bit more complicated, but it's really elementary. But what needs to happen under the hood is a little bit more complicated. Specifically, if you also want to control the value of lyrics from remote, like you want to be able to change the behavior, you want to be able to change this flag from remote. So we started, as I said, rewriting basically from the ground up, and we followed some principles when doing it. And today I want to walk you through some of our principles, and we will see during the talk why they're crucial and important for our architecture. So the first principle that we followed while developing is safety. So our lighthouse is and will always be to always deliver a consistent configuration. At Spotify, we deeply care about the user experience of our users, so we want to make sure that they always end up with a consistent and a valid configuration. We will see later what this means, but we want to make sure that the experience is always consistent and not broken for our users. We also designed a system that was fault tolerant. Specifically, we need to support a lot of offline scenarios. Maybe you are, I don't know, on a train or on an airplane, and we want to still be able to have a system that works correctly. And we relied a lot on default values. So all of our flags will always have a fallback scenarios where we can fall back if something goes bad, like there is no internet, there are no values. And also we try to bake in developer safety as much as possible. So we followed those principles typical of software development, like single responsibility, immutability, etc., and we baked in inside our own system. We will see some examples later. The second principle is ubiquity. The Spotify experience is shipped across a lot of different devices, not only Android apps. That's the reason why we spend a lot of time building SDKs that should support Android, iOS, web, and C++. As I said, we don't support only Android, but also iOS devices. And not only phone, also wearable devices, tablet, and automotive. And if you don't know, Spotify doesn't only have the so-called Spotify Music app, but there are a lot of other apps like Spotify Stations, Spotify Lite, Spotify for Kids. And all of those apps should be able to experiment. And the last principle is simplicity. So our motto here is it should just work. So we want to have a system that our developers internally, they should just be able to set up with a couple of lines and everything should just work smoothly. It should be really easy to use. So like it should not be that complicated really. And to achieve this, we baked in code generation in every possible step of our setup. And then we also spent time offering developer tools to support our developers, for example, in their daily work, if they're running the app and they want to see different experience, like debug menus and so on. And also in the testing. We deeply care about testing. So if we are offering two different user experience, we want to have the tools to write tests for those two different experiences. So now that I presented those principles, let me spend some time giving you a bigger picture overview of our architecture. So to explain our architecture, I need to introduce three actors. So the first actor is a developer, the second one is a data scientist, and the third one is a Spotify user. So it all starts from a developer. A developer wants to create a new rollout or a new experiment. So they basically create a properties.yaml file where they define all the flags. Once they create this file, they're able to build a new feature and use them inside their business logic. After they're done building the feature will be merged, and the properties will go through the so-called publish phase. The publish phase allows those properties and flags to reach one of our backend services called remote config admin. This is where we store all of our properties. Then is up to the data scientist. The data scientist will have all the configurations for setting up a new experiment or a new rollout. They will use a tool called Backstage. Backstage is a tool that allows them to interact again with remote config admin and send out all the configurations for running a proper experiment. Then is up to our mobile users. When they open the Spotify app, they go through the so-called resolve phase. The resolve phase is when the Spotify app hits another service that is called remote config resolver. And this service is responsible of giving runtime values to our mobile app. And obviously, we interact with the other service, remote config admin. So now I want to walk you through those dark green boxes one by one, and we will deep dive on each of those to understand what are like the nuances. The first one is the data scientist story. And as I said before, this talk is not really focused on data scientists, but I want to give like a short mention of Backstage. So Backstage is an open source tool we open sourced some months ago. You can find it on GitHub and on backstage.io. And it's basically a tool, a framework for building developer portals. So imagine that you have a web application where inside you have direct access to your CI tool, to the code source, to the documentation, to all the tools that are used by developers. And specifically, internally, we also have a plugin for Backstage that is used by data scientists to set up new experiments and roll out and see all the metrics, do all the evaluations that a data scientist needs to do. So I invite you to check out backstage.io. The next step is the build phase, so the developer phase. And this is like where the interesting part actually starts. As I said, it all starts from a properties.yaml. So let me introduce this properties.yaml. And let's see how it looks like. So that's how a developer can define a first flag. In this case, is a flag to control if lyrics are enabled or not. As you can see here, the properties are namespaced. So they're like player module dot lyrics enabled. And this is like a first form of ownership. Like with these syntax, we are able to always identify who is owning this specific flag. In this case, this is just a Boolean flag, but you can define others. For example, this is a hello message property, and here we can define an enum property, like with a list of all the possible values. And the next one is message size, that is the text size of a message, and is an integer property, where we can define like lower and upper bound. For all of those properties, there is always a default value. This is a requirement of the system. So once one of these files is ready, the developer can start building a feature. So let's go from the developer point of view. So they're working on the player module, and they have a new file called properties.yaml. Our experience is shipped as a Gradle plugin. It means that the developer will have a task called generate properties that they can just invoke. This task will take properties.yaml as input and will run code generation. Specifically, two or more files will be generated. One is a properties class, and then we generate Dagger module. This means that the output will look more or less like this: player properties.java and player properties module.java. Those two files can be used inside the business logic of the feature, and the developer can just start using them and writing the logic. As I said, we tried to build, we baked developer safety inside our system. So player properties is fully immutable. Like, you can't change the values once you got an instance. If you want to get an updated value of a flag, you need to get a new instance of a player properties. We also, we are strongly opinionated on type safety. Specifically, we decided to don't have string properties. Like, you can't have a string flag. That might sound odd, specifically if you worked with tools like Firebase Remote Config, where you can actually use a string. The idea behind this is that with our types, there is integer, enum, and boolean, we are able to sort of restrict the amount of possible values and prevent scenarios like developers sending source code in a string property, or developers sending JSON, or data that might like break the app in some way. We want like strong enforcement on data types. And we realized that with enum and boolean and integer, we are able to cover the vast majority of the experimentation use cases. Last point, we also enforced a strong ownership. As I said before, with this naming convention, and also we use Backstage again, because Backstage has the capability of give ownership to every source code file. In this case, this properties.yaml needs to be registered and needs to have an owner, so we can always pinpoint which team is owning this properties.yaml file. So we can always see like, hey, this is the team, we need to ping them, and we need to ask what's going on with this property. So from the developer point of view, it looks more or less like this. They go inside their build.gradle and they drop these 3 lines that enables the remote config plugin. And then there is a properties.yaml file that we already saw. And so let's have a look at how the feature code of a developer will look like. So for example, let's say that they have like a Dagger module with already all the dependencies, like this player module.kt. And they just need to include our generated properties module. That's really easy. This module already have all the provides for all the properties classes. So inside the business logic, let's assume there is a player presenter file. They just need to do injection of properties. That can be done like with field injection or constructor injections, like classical Dagger code, really nothing crazy. And inside the business logic code, they can actually write something like this: if properties.lyrics enabled. Here we reuse the same name of the properties. So we do like a camelization of the property name, and they can just like do their branching. Like if true, show the lyrics experience, otherwise show the default experience. This is the code that I presented at the beginning. But this is possible with code generation. And also I want to mention that using code generation in this field allow us to avoid a lot of common errors. For example, like a lot of basic experimentation framework requires you to write the string of the property or of the flag name. And if you have a typo there, or if you use like lyrics dash enabled instead of underscore, then you might end up in situations where you ship the app to the Play Store and you enable the flag and then nothing happens because you have a typo in the property name. That is really annoying. So using code generation helps us avoid a lot of common errors like this one. Let's see the second step. That is the publish step. Again, so the developer created a properties.yaml file, started building it, and now it's time to publish our properties. So again, player module, properties.yaml. In our code base, we have tons of modules. So imagine that there are a lot of other modules, the search, podcast, playlist, whatsoever, and all of them, they could have a properties.yaml. It's not mandatory, but they could define one. So we offer another Gradle task called publish properties. There is responsible of searching all the properties. so discovering them through the code base, and hitting our backend, remote config admin, and telling which properties are found. To fully understand this step, I need to mention that this is happening on CI and is happening on post-merge. So once the feature is ready, they can just click merge and this task will run and will publish all the properties. So why we do this? First, because with this system, we don't need to define properties twice. They're just defined inside the properties.yaml file. You don't need to log in inside a web UI and create a new property there. It will be taken from the code base and will be available inside admin, and all the other system that will use this property can benefit from this setup. We can run CI checks like static analysis on these properties.yaml to validate that the properties are valid, they use the correct naming, etc., etc. And also this helps us to achieve strict versioning. That means that we are always able for every version of the app to go back in time and see which properties were published. Because we can just check out the code base at that point in time and we run this task and we will find the same properties. And again, this is a huge power because we can rely on our code base as being the single source of truth. Like properties are defined only once, they are defined in the code base and they're nearer to the feature that are actually using them. This solves a lot of headache that we had with ABBA, where like, imagine again, this huge file with thousands of properties and like you don't know who owns what. Like instead, with this setup, it's really easy to understand the code and who is owning it. One little note. So at Spotify, to do code sharing between Android and iOS, we use C++. So imagine that there is an underlying C++ layer used, shared between Android and iOS. And also there, developers can define their properties.yaml. In the C++ layer, we have code, for example, for running music. And imagine that a developer there wants to experiment on the bitrate. So there are actually several properties.yaml file, and it's up to this Gradle task to find all of them. So now to the last step. Again, so the resolve. And this is the step that is happening on another front, the runtime part. So this is the step that is happening when our users are opening the Spotify app. Let's see it in details. So we do have several modules, again, the same that I showed before. And as I said, we do code generation. So we do have a lot of files, like Java files, that are generated by our framework. And then we also ship a runtime client SDK. So there is a part of code inside the Spotify app that is responsible of calling, like doing a network call to remote config resolver and getting a runtime allocation. So for a specific user, in a specific country, in a specific version of the Spotify app, get the values of all the properties. Then it's up to the runtime, like once the player module starts, to get an instance of player properties and ask the client SDK to get an instance of it. The client SDK will return a valid instance of player properties with the allocated value at runtime. And this is the same mechanism for all the features that require to have one valid allocation at runtime. To fully understand the resolve, I need to quickly mention what is our fetch strategy. So at Spotify, we use the so-called activate and fetch. This is a terminology that comes from Firebase remote config. So fetch is the action of actually hitting the backend. So it's this red arrow. So you do a fetch whenever you hit the backend and you get new values for all the properties. And you do an activate inside the client SDK when you make those values available for all the modules to be used. We will see this strategy a little bit more in detail in the next slide. But I want to mention that we also do recurrent fetch in the background. So we constantly keep on polling I mean, polling is probably not the correct term, but like we constantly in the background interact with remote config resolver to get fresher value to be used for the app. Let's see how the fetch strategy looks like more in details. So the user opens the app, and the first question that we ask ourselves is the user logged in? Like, is the user seeing the login screen, or they already logged in with the Spotify app? If they're not logged in, so that they're seeing the login screen, we do the so-called fetch and activate. So not activate and fetch, but fetch and activate. It means that we immediately reach our backend, we get a configuration, and we activate it immediately to make it available at the first run of the application. So this is the so-called first user session. We want to make sure that when you open the Spotify app for the first time, you will see the login screen. There will be like a loading spinner, and then you will see your correct experience. If you're already logged in, then we do the activate and fetch. So how it works. First, we load the remote configuration SDK, and we checked, is there a cached configuration? Like, do we have something that we fetched in the past? If yes, we just activate it. If not, we fall back to the default config. So after we do this, we schedule a delayed fetch. This is what I mentioned before. It means that the user will see the app, they will see the experience that was fetched for them in the past, and then they will activate what we have right now. In the future, like new fetch will happen, so newer values will be refetched for that users, and they will be available the next time you reopen the Spotify app. So this is also these scheduled delayed fetch are happening in every scenarios, and they allow us to be in constant connection with remote config resolver and make sure you have like up-to-date values. So now I want to share with you some lessons learned. So when building this kind of SDKs, we went through like several failures, things that didn't work as we expected, things that we would have done differently. So we want to share it with the rest of the community now, and maybe they might be helpful if you're also starting to develop like a system like this one. So the first one is correctness. So at the beginning, I mentioned that one of our goals is to always deliver a consistent configuration. So we truly believe in this. And this is also one of the reasons why we decided to follow this activate and fetch mechanism. And to let me explain this, I have like a simple GIF. So imagine that you have two buttons for confirming an order, and the user can click on yes or not. And then you do an activate at a certain point, and you change the experience because you have a pro tip banner to show on top. This will actually change the layout for the user and will basically end up on them clicking the yes button. That is extremely annoying. So the idea behind this is that we deeply care about the user experience, and we don't want to let our user experience like a fragmented app. For example, like if you're experimenting on the color of the buttons should always be of the same color, and you should not see screens with a red button and others with a green button. That's just like not acceptable. That's why we do this activate and fetch, and we refetch configurations, but they will be available for you at the next opening of the app. So for this, I also want to mention that make sure you cover every entry point to your app. In the diagram I presented before, I showed like the open the app entry point. Like on the left, there was open the Spotify app. How about if you have a deep link and push notifications? Like you need to take care that every entry point of your app is covered with the proper experimentation initializations. The problem is that if you don't do this, you might end up in a scenario that is called misbucketing. So if you have users that they should be in a certain group, like they should have a certain experience, but because they entered through a wrong entry point, like a wrong one entry point that you haven't handled, they will see a different experience. That's something that you want to avoid. Another lessons learned is think about differences between experiments and rollout. They are not the same thing. So this whole talk was about having values that you can control remotely, and you can use them to do both experiments and rollout. But actually, those two use cases are somehow different. And specifically because experiment, it's something that you run to evaluate the user behavior, to collect insights, like to understand what your user is doing and which screen of your app is the best. And the end goal is to make an informed decision. Like maybe you have, again, two shape of a button and you want to experiment on them, and the end goal is to decide which shape is the best to use. While a rollout instead can be used to test a new library or do a gradual release of a new feature. Or maybe you just have a kill switch that you want to control remotely. So the life cycle, for example, of those two use cases is really different. Experiment might run just for like a couple of weeks, while rollouts, they might run for months. So it's crucial for you to develop a system that adapts to your use cases, and also your users, like developers in your company, should understand what's the differences between those two. Then another crucial point is propagation time. So propagation time, let me explain it with an example. So the developer is building the feature and a data scientist is setting up the experiment. Then once the developer is done, there is a new release of a new version to the Play Store. And this, in our case at Spotify, we release every week. So this can take up to 7 days. Then once the app is out in the store, you can actually enable the experiment. You could potentially enable it before, but I mean, you need to press the button. That could be immediate, but even not. And then once you press the button, like once you go on your web UI and you enable a configuration to be true, from false to true, your users should start experiencing it. And this can go from minutes to days, like days. There might even be users that never experience what you changed over there. So this is called propagation time or ramp up time. And is the time between you coding the feature and your users actually experiencing it. And really, like, sometimes I really feel that developers just go on the web UI and they change the value and they expect that the value like is true for everyone. No, that's not actually the case. It might take days, specifically if you have a setup like ours, where like you do a background fetch of the values and you make it available only at the next start of the app. So you need to find a way to mitigate this propagation time. And here I have like a potential solution. So to explain it, I think it's also crucial to understand what is the implication of experiments with the app lifecycle. Specifically, there are the so-called startup experiments, or experiments that are happening early on during the app lifecycle. Let's say that you want to experiment on app startup, like the app starts and you want to go between two different libraries. And then you enable the value, like you want to use the new library, and then the app starts crashing. You need to have a way to wipe the so-called faulty configurations, because you enabled something that is crashing for your users. You might go on your web UI, you disable it, but all the users that have the value set to true, you need to be able to recover them somehow. There are multiple ways, like you could have like a counter of crashes, and if the app is crashing, I don't know, more than X times in a matter of minutes, just wipe whatever you have there. Or you can have like something like a push mechanism that allows you to clear broken configurations and also speed up the propagation time. This is something that Firebase remote configuration is doing, for example. Like it allows you to use Firebase cloud messaging to push configurations to your users. This is in beta right now. And then just to close, I want to mention a little bit like buy versus build. So this whole talk was on how we built our own system, and the idea was to share with you folks what was our story, what we built, what was our goal. But this doesn't mean that like every company needs to build something like this. There are a lot of valid alternatives out there, and I want to mention some. So if you want to like use something pre-built, Firebase remote config might be it's probably the de facto solution on Android. You can use other tools like rollout.io. If you want instead to build your own SDK, you can use something like Facebook Planout. This is probably the most cost-effective solution because you don't have to build anything. You rely on other tools, and it's probably the fastest. Like you will have something working in a matter of hours, days. But if you end up building something custom, this was like the decision for us. And specifically, we ended up with this for scalability reason. For example, Firebase remote config doesn't allow you to have more than I think 2,000 flags. And this was not the case for us. Like we would have already reached the limit. Then flexibility. Like in our case, we have a lot of custom metrics and we want to do a lot of data analysis on our experimentation. So we wanted to build our own system on it. And also safety. As I mentioned before, we built a system that was safe for our developers to use and it was safe for our infrastructure just to run. The end goal, and here I want to close, is, as I said, I work for an infrastructure team. So my customer at the end of the day is another Android engineer, like our other engineers in the company. And in this case, we deeply care about developer happiness. So we want to make sure that our developers at Spotify, they like our tools, they're able to do experiments, and they're fine with it. So that's why we decided to go for a build solution rather than using a third-party tool. That being said, thank you very much for listening. And we are hiring. So if you're interested in any position, just drop me a message. And I'm open to answer any question. Awesome. Okay, so did you begin, the first one is from Anonymous. Okay, so did you begin with this developer data scientist architecture when Spotify first started? If not, how smooth was the transition? Did you have to rewrite a lot of the code from scratch? No. So as I said at the beginning, our first tool was called ABBA. Then something like 1-2 years ago, we decided to reshape our approach. And we ended up building basically our new tools from the ground up. And actually, that was the occasion to actually split the tools into more logical tools. So like a tool for doing experimentation, another tool for handling metrics. And from the transition point of view, I mean, as every migration, it was complicated. We relied a lot on ownership. So also with ABBA, we had a way to find the owner of every flag. So it was somehow possible for us to allocate sort of like a migration task to every squad, to every team, and ask them like, hey, you have 10 flags, please migrate them. And then it was not really complicated at the end of the day. Like once every team was like pinged multiple times to do the migration, we were able just to like remove the flags and hardcode the values. And then obviously the older service will keep on running for the foreseeable future. But we saw like a really strong adoption of the system because developers generally liked it. Okay, so next one. How does this config interact with client version? For example, if a rollout of a new feature showed a bug, how could you then limit that new feature to only upstream clients that add a fix for the bug? So, yeah. So as I said before, we strongly rely on this publishing mechanism. So for every version of the app, we are able to specify which flags are are published and are available. And on our web UI, data scientists can see the range of possible versions that have that flag defined. If, like, for example, sometimes a developer might just decide to create a new feature flag. And if they remove the previous feature flag and they create a new one, the data scientist will be informed that the flag is not available. I don't know if this answers exactly your question. If not, feel free to ping me on Twitter and I'll be happy to follow up. So the next one is from Guilherme. Hey. And he asks, if consider a feature that is not shared between Android and iOS, what happens if iOS and Android define some properties, the YAML inside the module? Doesn't that break the single source of truth of the properties? It is on two places. So properties are client scoped. So if you define the same property inside Android and iOS, there will actually be different properties. Like we have a way to distinguish the client at the top level. If it's like music, Android, music, iOS, stations, Android, stations, iOS. And then for all of them, we have all the properties. So even if the file looks the same, it's actually like a different client. And there was like another question that they asked me if the tool is going to be open sourced. I want to follow up on that. It's not on the table right now, mostly because this is like a really customized tool that works on our internal needs. So it's really, it wouldn't be really helpful for others. It's not really like generalized as Firebase remote config that you can really like use that for any kind of experimentation. But really, we do a lot of open source. So feel free to follow up on github.com/Spotify. That being said, I don't think we have any other questions. Thank you very much for having me. Feel free to ping me on Twitter if I wasn't able to answer your question.